class. Now, today's class, I told you a function fx is said to be differentiable at x equals to c if limit x tends to c fx minus f of c upon x minus c exists. Now, this is same thing as when you put x as c plus h, you have limit h tends to 0 f of c plus h minus f of c upon h, that is f dash c, and we denote it by f dash c. So we have f dash c equals to limit x tends to c fx upon minus f of c upon x minus c if it exists. Now since it exists, its right hand limit and left hand limit are same. So we can say that function is differentiable at x equals to c if it has just these three equations values are same. Now if a function is differentiable at x equals to c, it's continuous at x equals to c, but not conversely. Now, since if it is differentiable at x equals to c, this will exist. Now, we have to show that it's continuous. That means limit x tends to c fx equals to f of c, or we have limit x tends to c fx minus f of c equals to 0. Now, we will consider limit x tends to c fx minus f of c. Now, multiply and divide by x minus c. We have this, we can separate it out. This is f dash c, and c minus c is 0, so that's 0. So we got that if the function is differentiable at x equals to c, it's continuous at x equals to c. Whereas converse is not true. That means function is continuous everywhere, but it's not differentiable. Now fx equals to mod x if x is greater than or equals to 0, minus x if x is less than 0. Now fx is continuous. Now right hand derivative is limit x tends to 0 plus fx minus f of 0 upon x minus 0. Now you can very well see when x is greater than 0, fx is x. So you'll write x here. And when x equals to 0, it's 0. So x minus 0 upon x minus 0, that's 1. Whereas left hand derivative, you have fx is minus x when x is less than 0. So it's minus x upon x is minus 1. Now as right hand derivative is not equals to left hand derivative, function is not differentiable at x equals to 0. Now we consider another function fx equals to 2x square minus x, x is greater than or equals to 2, and 7x minus 8, x is less than 2. Now you have to find f dash 2. Now right hand derivative is limit x tends to 2 plus fx minus f of 2 upon x minus 2. अब जहाँ x greater than 2 है वहाँ लिखेंगे हम 2x स्क्वायर, वहाँ लिखेंगे हम 2x स्क्वायर माइनस एक्स, f of 2 6 हो गया अपॉन x minus 2. तो when you factorize it, you have 2x plus 3x minus 2. This will cancel and you will get 7. इसी तरह से लेफ्ट हैंड डेरिवेटिव में 2 माइनस, तो 2 माइनस में you have 7x minus 8, f of 2 is minus 6 upon x minus 2. This is 7 common and it's 7. So right hand derivative equals to left hand derivative equals to 7. So f dash of 2 is equals to 7. Also class, when we have fx equals to, now just a minute. Now see, in this question, function is continuous at x equals to 2 because right hand limit is 6, left hand limit is again 6. So it's continuous at x equals to 2. Now at x equals to 2 पे अगर ये continuous है तो हम डेरिवेटिव डायरेक्ट ले सकते हैं. इसका डेरिवेटिव क्या हुआ 2x स्क्वायर का डेरिवेटिव. डेरिवेटिव ऑफ 2x स्क्वायर इज 4x माइनस 1, इसका 7. यहाँ x को 2 डालेंगे, ये 7, ये भी 7 आएगा. तो जहाँ फंक्शन जिस पॉइंट पे कंटिन्यूस हो उस पर हम डायरेक्ट डिफरेंशिएट करके उसकी वैल्यूज़ फाइंड कर सकते हैं. बट एग्जाम्स में हमें ये एक्चुअली पूरा सॉल्व करना पड़ेगा. Now for this question you will see that it's not continuous, so it's not differentiable at x equals to 1. Now right hand derivative is limit x tends to 1 fx minus f of 1 upon x minus 1. So this is x plus 1 minus 2 upon x minus 1, that's 1. Now in left hand derivative this is limit x tends to 1 minus fx minus f of 1 upon x minus 1. Now this is x minus 1 minus 2 upon x minus 1, so that's not defined. Now as right hand derivative is not equal to left hand derivative, function is not differentiable at x equals to 1. You can very well see again, since this function is not continuous at x equals to 1, it's not differentiable at x equals to 1. Now next one, show that fx equals to mod x cube. This is x cube if x is greater than or equals to 0 minus x cube if x is less than 0. It's differentiable. And find f dash x. See, f dash x वैसे क्या होगा? f dash x वैसे तो होगा लिमिट x टेंड्स टू c एफ एक्स माइनस एफ ऑफ सी अपॉन एक्स माइनस सी. या इसको अगर हम जनरल लेना चाहें तो ये भी ले सकते हैं, x टेंड्स टू सी एफ एक्स माइनस एफ ऑफ सी अपॉन एक्स माइनस सी. ये एफ डैश सी हो जाएगा. अब एफ डैश एक्स क्या होगा? एफ डैश एक्स तो यही होगा लिमिट h टेंड्स टू 0 एफ ऑफ एक्स प्लस एच माइनस एफ एक्स बाय एच. तो अगर हमें एफ डैश एक्स फाइंड करना है तो हम यही डेफिनेशन ले सकते हैं, एफ ऑफ एक्स प्लस एच माइनस एफ ऑफ एक्स अपॉन एच. तो दिस इज लिमिट एच टेंड्स टू 0, दिस इज एक्स प्लस एच होल क्यूब माइनस एक्स क्यूब बाय एच. इसको सॉल्व करेंगे, ये हो जाएगा लिमिट एच टेंड्स टू 0 एक्स क्यूब प्लस एच क्यूब प्लस 3x square h plus 3x h square minus x cube upon h. Now this is 3x square plus 3xh plus h square limit h tends to 0. So that's 3x square. तो f dash x फाइंड करने के लिए हमें खाली ये डेफिनेशन यूज़ करनी पड़ेगी. इस तो उस पर 3x स्क्वायर आ जाएगा. 3x स्क्वायर का डेरिवेटिव फिर हम इसी तरह से करेंगे, वो 6x आ जाएगा. तो हेयर f double dash x is 6x x greater than or equals to 0 minus 6x x less than 0. क्लास वैसे ये क्वेश्चन मैं कल क्लास में डिस्कस